We're at the end of the unit, so this is lesson 41, and now we're going to review all the different transformations we've done. So I will be restating and annotating each problem, differentiating the different types of transformation using the information on the graph, and watch how, again, we differentiate between a similarity and congruence. Welcome back, Math Marbles. In this lesson, we're going to look at series of transformations and get some more practice in to just do some more review and some more quick thinking. So in this one, we're going to look at series of transformations and try to figure out how can we map this out. And so when I think of maps, a lot of times I think of Dora the Explorer, who really showed us a sequence of ways to get from one place to another. Like, you know, she would go from the river to the tree to the castle. So I want us to think about how can I go from this figure here? What could I do to this figure to get to this figure? Like, what could be a series of transformation? What changes can I make? Thinking about the kinds of changes we have, it's definitely not a dilation because it's still congruent. I still have a 4 by, in this case, 8 rectangle. So I have 4 by, 8. So they're congruent. So I can use either a translation, a slide, a reflection, and a rotation. So slides, flips, and turns to make one image turn to the other one. So that's going to be our goal. And look at the points. So how can I make my H? I'm going to start just with point H. Move from there to here. Could I do it in two different ways? So just by thinking, I think the easiest pathway, the first thing that comes to mind is I kind of want to get this over to this side. So I want this to come over here. And so that means this is either going to be a reflection or a rotation. So think about this. Would it make more sense to reflect it over here and have the same image? So it would look like, would that make sense? And then do another change? Or should I rotate? And again, remember when we rotate in this way, it's going to be counterclockwise. My rectangle is going to go from this to turning over. It's going to look like this. It's going to turn on this side. I think I'd rather this. So I'm going to rotate it 90 degrees. So here's the first thing I'm going to do. I want to rotate 90 degrees counterclockwise. That's going to be my first change. So let's look at my points. And when we rotate 90 degrees, we know that these flip and the first coordinate is going to be an opposite. Okay, so we know that is going to be true. So H is going to go from 2, 8. And it's going to become -8, 2. That's going to be the first one. So -8, 2. So that's going to be my first new H. All right, and then I know L is going to go from 2, 4 to -4, 2. So -4, 2. Here's L. Points are going to be, let's do J, and we're going to have K. In case you need to see it, here it is again, -y, X. So they flip, and the first one is this opposite. And J is going to go from 10, 8 to -8, 10. And I can figure out what my last point is going to be. It's going to be right there, isn't it? K, which is 10, 4, which is going to be -4, 10. Yep, -4, 10. Makes sense. J, and here's K. All right, so let's draw this out. There we go. All right, so we have our first part. So we have a rotation. Now, what do you think my second change is going to be? I cannot just reflect it because if I reflected it, these points would be right here. So that's not going to work. It looks like it should be a translation. And that makes sense because look at where my H is and look where my other H is. So I have to get from here to here. It doesn't make sense for this to be a reflection where an H would be here. So I have to get from here to here. So here's my second one. It's going to be a translation. I'm going to move, I like to move this way first and then down. So I'm going to move over 2 and down 12. So I'm going to move this way to the right 2. And then I'm going to go down 12. These are my movements. Just erase. So right 2 and down 12. And that will get me to my points, right? So H over 2, down 12, over 2, down 12. So my H and my L will match. Over 2, down 12, over 2, down 12. My J and my K will match. So this is one series, and to be fair, Math Marvels, there may be other ways to do this. So if you find another way to transform these two images, please share them with one another because there's always different ways. But these are the two that made the most sense to me just by rotating it this way and then doing a translation slide. So hit pause and jot this one down. And let's do one more together. Okay, here we go. We're going to use rays here. We have triangle BCD is rotated 180 degrees counterclockwise. Remember, it doesn't matter if it's counterclockwise or clockwise because it's 180 degrees. And then it is dilated by a factor of 3 centered at the origin, resulting in a new triangle. So what statement has to be true? So we know this is a geometry question. We know that it's rotated 180. So we know pretty much XY is just going to become, they're both going to be the opposites. So we know that's going to happen. And then we know that there's going to be a dilation. My scale factor, SF, like my initials, of 3. And we know that means that I'm going to take whatever my X is and multiply it by 3 and whatever my Y is and multiply it by 3. So I've mapped out all the things. So we want to figure out which things are going to be true about this triangle. Okay, so think about it. If I have a triangle, I'm moving it over, I'm rotating it. So if my triangle was here, now my triangle is going to be flipped over here. It's going to be on the opposite side. It's almost as if I have a line of symmetry happening right here, right across. And I then know it's going to have a scale factor of 3. So I know the size is going to get bigger. It's going to be 3 times bigger. So those are the things I'm mapping out in my mind. So let's see if we can eliminate any of these here. The perimeter of BCD is 3 times bigger. So let's say this side, each side was just, let's just pick numbers, 1, 1, and 1. Now if they're 3, each side is 3 times bigger. I'm not too sure of that one until I draw it out. So we're gonna try drawing that one to see if that one is true. So let's skip to the next one. The area of BCD is 3 times the area of the other. So again, I kind of want to map one out, and I feel like we need a better triangle to really map this out. So we're going to draw a different triangle here. C, the corresponding angles are congruent. That one I absolutely know it would be true. My angles would stay congruent. They would stay the same whether or not the figure is bigger or smaller. So I know this has to be true. I'm sure about this. And the sides would be congruent. Yeah, no, the sides would not be congruent because the sides would be different. So I'm absolutely sure about C. It seems like the best choice right now. I know it's true. For A and B, I don't have enough information. Because I don't have points, I could make something up and make this harder for myself, but I absolutely know that C is true, that the angles themselves would stay the same, even though the scale is changing. So I'm going to choose C for this one. Let's go to another one. And I hope this makes sense why I'm not going and drawing these other ones, because I absolutely know this one is true. And I just don't have enough information, Math Marbles, to know anything about the area or the perimeter. Unless I have points, I can draw something, but how do I know it's absolutely true for all cases? But I do know in this case, the corresponding angles will be congruent. Well, that's going to be the end for this lesson, Math Marbles. So we're gonna stop there.